Okay, we are practicing assigning oxidation states. And if you take a look at the first problem, H2O, remember I told you that if you have hydrogen or oxygen in a compound, you assign them first. So here, you know that hydrogen is a +1, unless it's with a metal, and oxygen is a non-metal. You know that it is usually a -2, and the oxidation numbers it up to 0 in a neutral compound. So this +2 on the hydrogen, the two hydrogens at a +1, that's a +2 overall. If you add that with a -2, that's 0. So we're done. The next one, Li2O2. Li is a metal. It is in group 1A. Anytime you encounter a metal in group 1A, it's pretty safe to assume its oxidation number is the same as its charge in the periodic table, which is a +1. When you see O2 with a metal, then be suspicious. It might be peroxide, and in this case it is. If you have two lithiums at a +1, that means your oxygen has to have a -1 oxidation state because you have two of them and the oxidation numbers have to add up to 0. So this is +2 and a -2, they add up to 0. AgMnO4, assign oxygen first. Oxygen is usually a -2. Then what you want to do is assign the silver. The silver is more electronegative than your manganese, but silver usually has an oxidation state of +1, which is the same as its charge. So we put the +1 on the silver. Then what we're going to do is calculate Mn, because we have no idea what its oxidation number is. So if you have silver at a +1, plus manganese, plus 4 oxygen at a -2. The oxidation numbers add up to 0 because there was no charge written in the problem on the paper. So here, a +1 and a -8. 1 minus 8 is -7. Put the 7 on the other side. Manganese is going to have an oxidation number of +7. Okay? For the next one, K2Cr2O7, assign oxygen its usual oxidation state of -2, and then assign potassium a +1, because potassium is a metal in group 1A, and the metals in group 1A tend to have an oxidation number that's the same as their charge. Then we're going to calculate chromium. If you have two potassiums at a +1, and you add that to chromium, of which you have 2, which means you should put a 2 in front of the chromium. And then you're going to add that to 7 oxygen at a -2, and the sum of the oxidation numbers is 0 because this is a neutral compound. There's no charge written on the paper. So 2 plus 2 chromium minus 14 equals 0. 2 minus 14 is -12. And then put the 12 on the other side. Divide by 2, and you're going to get chromium has a +6 oxidation number. Now, for the last one in this column, AlH3, this is hydrogen with a metal. This is a metal hydride. This is when hydrogen does not have a +1 oxidation number. It has a -1. So if you have 3 hydrogens at a -1, this is -3 on the right, you would have to have a +3 on the aluminum so that the oxidation numbers add up to 0. For NH4 +1, assign hydrogen its usual oxidation state of +1, and we need to figure out what nitrogen is. This is a polyatomic ion with a +1 charge written on the paper. That means the sum of the oxidation numbers will be that charge. So nitrogen plus 4 hydrogen at a +1 add up to 1, which is that overall charge on the ion. So this is N plus 4 equals 1. Put the 4 on the other side. Nitrogen is a -3. OF2. This is one of those examples where oxygen is not going to be a -2. Oxygen is going to be the opposite, which is a +2. And then fluorine, which is in group 7A, is more electronegative. It has the same oxidation number as its usual charge, which is a -1, because a +2 and a -2 have to add up to 0. For CaNO3 2, assign the oxygen its usual charge, which is a -2. And then since calcium is a group 2A metal, it is safe to assume that its oxidation number is the same as its charge, which is a +2. Okay? We need to figure out what nitrogen is. So calcium at a +2 plus 2 nitrogen plus 6 oxygen at a -2. Add up to 0 because there is no charge written on the paper next to the example. So 2 plus 2n minus 12 equals 0. 2 minus 12 is a -10. Throw the 10 on the other side. You're going to get nitrogen is a +5. ClO3 -1. Assign oxygen its usual charge, which is a -2 as its oxidation number. We've got to calculate chlorine. So if you have chlorine plus 3 oxygen at a -2, it adds up to -1 because that's the overall charge that's written on the paper for this example. So Cl minus 6 equals -1. Throw the 6 on the other side. You're going to get chlorine is a +5. Last example. I think I'm going to need some space for this one. All right, let's assign what we know. You know oxygen is a -2. You know hydrogen is a +1. So what I recommend you do now is between carbon and nitrogen, assign, it's not really safe to assign. It's actually a little bit more complicated than that. So let's make some space here. I'm going to go ahead and take a look at this carbon first, okay? So you've got a polyatomic ion. You've got 2, actually, that came together. This is the carbonate ion, which has a charge of -2. So if you think of it that way, you have a carbon plus 3 oxygen at a -2, and that charge typically adds up to a -2 because that's the overall charge on the carbonate ion. So C minus 6 equals -2. Carbon is going to be a +4. So we're kind of piecewise solving the oxidation numbers in this compound, okay? So we found out that carbon is a +4. Now we can go ahead and calculate nitrogen, okay? For this you have 2 times 2 is 4 nitrogen, plus 2 times 5 is 10 hydrogen at a +1. Plus, you have a carbon at 4, and then 3 oxygen at a -2. So the oxidation numbers add up to 0 because there's no charge written on the paper. So 4n plus 10 plus 4 minus 6 equals 0. 10 plus 4 is 14. And then 14 minus 6 is 8. Put the 8 on the other side. 4n equals -8. Nitrogen is going to end up being a -2. And now you're done.